I'm going to be, as Dr. Giuliano said, I'm going to be talking about the operational considerations for heavy-duty trucks. And specifically, we're going to be looking at the Los Angeles area. But I want to explain that this was part of a larger study for the AQMD that investigated market potential for heavy-duty zero-emission trucks. And the study itself had two different elements. Determining the impact of these zero-emission trucks on costs and GHG emissions, as well as studying the fleet operational impacts. And so this actually looks at the latter part, and it's become part of my dissertation. So before I even get started on anything else, the whole research team is listed on the right-hand side here. Dr. Giuliano led this, the entire effort, but the person that I worked most closely with is Jane Fang, and I don't think Jane's on the line today. I invited her, I wanted her to come, but so she helped with all the data analysis and all of that. She is a master at data manipulation, to be sure. So, but the research questions that we wanted to address is, can the zero emission heavy duty trucks handle operational requirements of firms? So of course, when we're looking at these types of firms that use these heavy duty equipment, you know, they have certain demands, they have to deliver things on time to their customers, they can't have a lot of downtime, those kinds of things. So, you know, they have to be able to fit into the way that they need to do business to make a profit, to continue to operate. So, you know, what are the hurdles for the firms to embrace the technology? And some of the other things that we wanted to find out was what are the experiences and perceptions by the fleet operators, and then would they even consider buying one of these? So we approached this from two different fronts: interviews, the in-depth interviews of fleet managers, and then case studies. We also did another preference survey, but I'm not going to talk about that. That was actually handled by Dr. Steinmetz and Dr. O'Brien from Cal State Long Beach, but I'm not going to include that in here since I wasn't involved with it. So before we move on, I just wanted to lay the groundwork and quickly review the landscape for truck traffic use in Los Angeles. So we see the Los Angeles central area, including the Inland Empire. And as we would have expected, but we ran the data to make sure that it corresponded with what our thoughts were, is that there's three major clusters of freight activity in the LA area region. And so one is near the port, so that's down here at the bottom, through the corridor up through San Rancho Dominguez area. And then the second one is near the Los Angeles downtown area and Hobart Yale Intermodal Rail Station. And then the third one is out here in Rancho Cucamonga in Ontario, where if you've ever been out there, it's just called the land of warehousing, really. So when we overlaid, this map actually has three different overlays on it to create these hotspots, and it has the truck trip intensity, and it also has employment for warehousing and those things. So anyway, we wanted to focus on the drayage activities, which coming out of the port is about 16 to 20,000 containers a day. And that's truck traffic that's coming out of that area. So you can only imagine, you know, if you've ever been on the 710 freeway near that area, it's kind of scary sometimes. So that is our landscape about what we're looking at. So first of all, I wanted to talk about the interviews that we did. And so the objectives were, how familiar are the drayage operators with alternative fuel trucks, and what, if any, reservations did exist for them? So I sat down and had quite lengthy interviews. It was a semi-structured interview, but then I did let them tell me other things that they wanted to tell me about as well. But as you can see from the chart at the right, some of the concerns that they had were mostly truck costs. Now, these alternative fuel trucks, there's not very many of them out there right now. And just like anything with economics of scale, they're very expensive. They can be 3 times as expensive as a regular diesel truck, and they have a lot less performance capability. So there's pretty much high hurdles to get over with these. So the truck cost is the number one, followed by the charging equipment cost, which is also very expensive that they would have to put in at their fleet operations. The charging time for actually powering up, if it's battery electric, performance issues. Unfortunately, there got a lot of press that some of these vehicles, they ran out of juice on the freeway and had to be towed. So that was actually mentioned by quite a few firms. So one of the firms actually was involved in the demonstration. So there's lots of money being pumped in for generations from the state of California to do some technology forcing on the part of these OEMs to get these trucks out there tested for operations. So, but the key point is here is that 67% would consider purchasing if costs were not an issue. They really do want to do things that are right for the environment. But the big issue here is that the minimum range that they would need to have these trucks to go is on average was 287 miles. And right now it's between 70, 100. At the very long set, it's like 130. Some of the new Volvo trucks are like 150 mile range. So, and that's a lot compared to the 70 miles. So a lot of different things. So range, I was expecting to be much higher. And as you can see, it was only 67% was on their concerns. But anyway, so then when we start talking about the case study here, the case studies that we did were looking at 2 firms, and they couldn't have been more different. They were, the first firm was chemical, liquids, and dry bulk, where the second firm was natural food delivery. So yeah, you can't get more different than that. The first firm owns all their trucks. The second firm leased all their trucks. The first firm operated only 1 shift a day. The second firm operated 3 shifts a day on most things for a truck. They really ran those lease trucks. And firm 1 had a different type of, they use their own employee drivers plus owner operators, which are contract workers, whereas the other firm 2 only had their own drivers. So you can see that we couldn't have picked 2 different firms. So before we get into what the data is, I need to tell you about what our assumption was. We were saying that our assumption is that they can only charge at their yard location, and they'll charge once a day, and it will be 4 hours for charging, and they can come back and they can do a tour. So an individual trip would be going between each of these nodes, and a tour would be coming from the charging equipment all the way back to the charging equipment again. But of course they couldn't charge during the middle of the day because that would take too long. Okay, so the data that we collected here, we had 2 months for firm 1 and only 1 month for firm 2. We collected data every day for every single stop they made during the day of geolocational data, so we could actually make maps of that. We had load weight, load type, truck type, and then the distance in miles. Some of these things we actually had to create based upon the data that we were given. Some of the things that in the actual weight, we had to make some assumptions on that. If the weight was more than 0, we assumed it was a fully loaded container. And if it was equal to 0, we assumed it was an empty container. And just to let you know, these things, they're heavy, just even when they're not loaded. We assumed that they were 40,000 pounds with the BEV tractor and empty container. And they can take up to 80,000 pounds on the road. So one of the things that weight is important is because of the fact that that makes you have to pull more, which means you have to use more juice to make it so. So that was an important consideration for us. So just to let you see very quickly here what the locations of the customers and where they were going on the day, you can see that for firm 1, there's in those 3 clusters, right? So Long Beach area up to LA, out to Ontario area, and then some other hot spots. And then looking at their data here is really interesting because, like I said, a single tour distance is going from their home base back to their home base. But they had many of those a day. I think that for this particular firm, it was 3 per day. But it's the daily distance that we're really looking at, right? If they're only charging once a day, it doesn't matter if they're coming back without being able to charge. So we come here and we see that the daily distance, more than 120 miles, is 56% of their trips on average for that day, for that month. And this was for October 2018. So for firm 2 had a different type of distribution. And again, they're making a lot of different stops because they're delivering food to grocery stores, and they're going all the way actually down to the border in San Diego. So a little bit different, and then they go all the way out past Palm Springs and on the 10 freeway out towards that area. Then you can see here that they actually go on a daily distance farther than 120 miles, but they're also using their trucks for a longer period of time during the day as well. But this has very different distributions. So keep those things in mind. So the summary of the distances here, again, for firm 1, for the daily distance, here for month 1 and month 2, a little bit different for each one of those, but still around 50%, and firm 2 is 66%. And as I was talking about, these vehicles are not the BEV vehicles anyway. They're just the new ones are going more than 100 miles with a fully not a full tank of gas, but a full container load, right? So getting to this particular slide, this really shows what if they were going to be looking at purchasing a truck at the current moment in 2020, what percent of their workload, based upon all these trucks that we were looking at, and we did look at every single truck that they were running in their fleet for this period of 1 month, what percent could they run? And so we utilized the battery capacity, which was used in the simulation study, which was the first part of the study itself. So we were joined with those particular results for 2020, 2025, and 2030. And you can see here that without weight limits, that they could run right now, firm 1 could run 30% of their business, but with weight limits, 18. In 2030, it jumps up because of course, the battery capacity and the efficiency is supposed to get much greater. But if you get down to firm 2, it's dire, especially in 2020, because of the fact that this was a lot not driven by, there was a little bit of a difference with the weights, but it was mostly driven with the time that they had to charge. Their trucks are on the road all the time. They don't have those 4 hours. So it's not until you get the range that's available here in 2030 that they could even consider it without the weight limits. But even with the weight limits, this particular business would have to change the way that they do their operations significantly to make this technology work for them. So the conclusions here is that the drayage market, it couldn't be so very different. There is so many different types of firms delivering different types of commodities. And so we need to actually look at particularly certain aspects of the drayage market to get these vehicles in first off. As I mentioned, that battery electrics are heavily influenced by range and weight. So as we can get these batteries much more efficient, that's really is the key to adoption. They are making a lot of progress. Early adopters can cherry pick those particular tours. Maybe they can pick out those particular, like I said, the 18% that they could actually run. What are those 18%? But one of the big things is down on the bottom here is many institutional operational barriers. If you have owner operators that only have one truck and they're given a certain route for the day and they can't handle that route, then basically they don't have work for the day. So they can't cherry pick their routes. They can't cherry pick potentially their work. So this is something that CARB and is really looking at as well, is how this particular technology is going to affect this group of people. Also, where are they going to charge? Where are owner operators going to charge if they can't charge at a fleet location? There aren't any right now. There's no charging infrastructure out there in the field for trucks. There might be for cars, but it's a very different circumstance. So the next step really is to add additional firms. I got some more data for a firm, and so I'm going to start doing this for another firm. And we'd like to also look at this from hydrogen and natural gas hybrid trucks as well.
So I know you mentioned weight was a concern with batteries on these trucks. I'm just wondering if there's been any kind of conversation in the policy space about the impact this could have on roads and road networks.
That's a really good, that's an excellent question, because of the fact that right now, 80,000 pounds is the limit for a Class 8 truck on the roads, due to damage of the roads and those kinds of things, because that's pretty heavy, right? The battery itself and what we utilized in this study as far as our assumption is, I believe we used 5,000 pounds as the weight of a battery. But batteries actually for the demonstration trucks are varying up to like 7,600. I even saw one for 9,000 pounds. So if you're looking at that 80,000 pounds, what does that mean? That means if you have to keep it within the 80,000 pounds, that's less payload that you can have too. So that even decreases the efficiency of the operations even further if you are fully loading up your vehicles. Like the firm one, the chemical firm, they run heavy because that stuff is heavy. Now the food folks were not necessarily always filling up weight-wise on their truck. It might be actually cubing out, but not weighting out. So that's something. However, that they have recognized that this is an issue, and so they're saying from the state perspective anyway. And I only know about California. But California is more advanced in doing these demonstrations and everything than the other states are at this point. So if increasing the amount of weight that a truck and their payload can be over 80,000 pounds. But I don't think that they've come to a determination about what that weight is. But it can't go up too high because, the loads on bridges and some of this other stuff. So anyway, but great question. It is being discussed though.
Thank you.